Chapter 5 Newton's Laws of Motion. Introduction. The study of motion is called kinematics, but kinematics only describes the way objects move, their velocity and their acceleration. Dynamics is the study of how forces affect the motion of objects and systems. It considers the causes of motion of objects and systems of interest, where a system is anything being analyzed. The foundation of dynamics are the laws of motion stated by Isaac Newton. Force. We can define force as the push or pull on an object with a specific magnitude and direction. It can be represented by vectors or expressed as a multiple of a standard force. The SI unit of force is called the Newton, abbreviated N. Free body diagram. A sketch showing all external forces acting on an object or system. The system is represented by a single isolated point, and the forces are represented by vectors extending outward from that point. Newton's first law. Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed, unless it is acted upon by an external force. Inertia, the ability of an object to resist changes in its motion, in other words, to resist acceleration. Newton's first law is often called the law of inertia. For example, it is more difficult to change the motion of a large boulder than a basketball, because the boulder has more mass than the basketball. In other words, the inertia of an object is measured by its mass. Newton's second law. Newton's second law, which states that the force F acting on a body is equal to the mass m of the body multiplied by the acceleration a of its center of mass, F equals ma, is the basic equation of motion in classical mechanics. In physics, however, there is an important distinction. Weight is the pull of Earth on an object. It depends on the distance from the center of Earth. Unlike weight, mass does not vary with location. The mass of an object is the same on Earth, in orbit, or on the surface of the Moon. Mass is the quantity of matter in a substance. Weight can be denoted as a vector because it has a direction. The direction of gravity, and hence weight, is a downward force. Newton's third law. Whenever one body exerts a force on a second body, the first body experiences a force that is equal in magnitude and opposite in direction to the force that it exerts. Forces always occur in pairs, and one body cannot exert a force on another without experiencing a force itself. We sometimes refer to this law loosely as action-reaction, where the force exerted is the action and the force experienced as a consequence is the reaction. For example, when a person pulls down on a vertical rope, the rope pulls up on the person. Common forces. Normal force. Force supporting the weight of an object or a load that is perpendicular to the surface of contact between the load and its support. The surface applies this force to an object to support the weight of an object. N equals mg. Tension. Pulling force that acts along a stretched flexible connector, such as a rope or cable. T equals W equals mg. Friction. Friction is a resistive force opposing the motion or its tendency. A spring force. A spring is a special medium with a specific atomic structure that has the ability to restore its shape if deformed. F equals negative kx.